Hey guys, so we're going to just spend the next 3 days reviewing for our benchmark, and we're going to do it with short little videos, just reviewing a couple of skills, and then we're just going to practice. So let's go through these real life graphs. Alright, so Lee is working out. This is a time and speed graph. This will tell me sort of how fast he's going and when he's moving. So let's just go through and see what each parts of these graphs mean. From minutes 0 to 10, he's increasing at a constant speed, which means that he might be running, he might be walking quickly, but either way, his speed is increasing at a constant speed. Now, this flat part here, as it goes out, the speed stays the same, but time keeps going. And since the speed stays the same, this could mean that he's stopping to rest maybe, or sitting down, but the speed isn't going anywhere, but time keeps going. Then I see the graph go up again at a constant speed, so he's picked back up his workout. Then I see that he rests again, because again, time keeps going, but he isn't moving. Then he slows down at a constant speed, so he's still moving, but his speed is going down. And then again, he tops out and stops moving, but time keeps going, and then he slowly decreases at a constant speed, which might signify maybe the cool down part of his workout. So when we're looking at these graphs, we need to put real life context on them as to what the graphs actually mean. So be on the lookout for these. These are going to be on our practice today, and let's go on to our next example. Alright guys, we haven't done this in a little while, doing solutions with substituting in coordinate points, but it's a similar idea. So our question, is -1, a solution to the following systems? So what I'm going to do is I'm going to take my coordinate points, which are -1 is my x value and -1 is also my y value, and plug them in to our equations. And again, it has to work on both equations for the solution to be, for the coordinate point to be a solution. So my first equation, I want -4 to equal -4 on both sides. In my second equation, I want -12 to equal -12 on both sides. So let's just start with our first one. If I have x plus 3y equals -4, I'm going to substitute in my coordinate points. So instead of x, I'm going to write -1. I keep my 3. I'm going to create a pocket in place of y, and in place of y, I'm going to add -1, and that all equals -4. Now, -1 comes down. 3 times -1 is -3 equals -4. -1 minus -3, keep change, because it's subtraction. I get -4 equals -4. So this coordinate point works for my first equation. Let's see if it works for our second equation. I'm going to write 3, pocket. -1 goes in my pocket in place of x. Plus 9, pocket. -1 in place of y equals -12. 3, I see that 3 and -1 are squished together, which means multiplication. 3 times -1 is -3. And then 9 is squished together by multiplication to -1. 9 times -1 is -9. And that equals -12. I just bring my -12 down. 3 minus 9, keep change, becomes -3 plus -9. -3 plus -9 is -12. And since it's equal on both sides, this coordinate pair is a solution. So this coordinate pair works. Alright guys, that was a short video for today. Let's go ahead and just get into practice.